I have been working on behavioral type checking. So that's what's on my mind. I don't know what's on anybody else's mind.
I had a few questions just on the status of the current dev. They're quick questions.
Start there.
Sure. So do the deploys in the dev branch today require signatures?
Not last time I checked. I don't know if they've changed anything.
Okay, and then a related question is, do they require real test revs? And I assume that's no also. That seems like that would depend on the other one.
Right.
Okay, that's I think my main questions. I need to sync up with, Kelly, Chris, Lidu, someone to understand the wallet progression a little better. I'm watching the check-ins, and so the only thing I've seen that is directly related to the wallet work is the rev address was exposed in Rolang a day or two ago, and the construction of the new rev address was either finished or progressed.
So, yeah, I haven't quite understood why they're making something other than registry URIs, but oh well. Seems like they reinvented the same thing, but
yeah, I haven't been following the details. It's sort of Ethereum-like, but there you go.
Right.
Okay. Any other topics for today?
I have a quick question about the registry. Jim, you keep saying that we lose the registry every time we have to reboot. Is that true only in the case of a standalone setup, or?
No, you can't restart in any configuration and not risk losing stuff. Now, we don't always lose the registry right away when we restart, but we seem to lose it very soon.
So even if you had two nodes connected together and one of them had to be restarted, you lose the registry?
Well, you'd have other problems. You wouldn't be able to catch up in the blockchain yet. They're still working on that.
Okay. Thank you.
Hey, Dan, with behavioral types, I've heard explain, what behavior types is and what the advantages are, but it'd be interesting to kind of get your take on what behavioral types is and the benefits it's going to provide us. What's your motivation on creating behavioral types? Why are you motivated to do this part of the project?
Well, there's two angles. One is not necessarily behavioral types, but sort of any kind of types that will keep you honest from. Right now, if you're writing Rolang, it's extremely tedious because you only get feedback at runtime about whether your program's okay or not. So if you forget an argument, your code just hangs. Mm-hmm. It just makes no progress. So that's just one angle. This is a practical coding angle. The other thing is the channel-based security. Where'd that go? This channel, the identity and agency channel. Anyway, the behavioral types lets you do stuff like, okay, if you start this process going, then eventually everybody in this group will know this secret and nobody in this other group will know this secret.
Okay.
So it can express things like that. And then if you are able to mix in quality of information, like somehow you could say, uh, everything that comes out of this process, everything emitted by this process is like either true or widely believed or something like that. You could type check some implementation of Twitter and say this implementation of a social networking system is more likely to spread truth than lies.
Okay. And the example that I recall that helps me kind of understand it is on your screen you have the DAO bug typing. So apparently with Ethereum there was a contract that was created that had an issue, and because and that smart contract was created by by just somebody, but it was in the Ethereum ecosystem, and because of that hole in that bug in that smart contract was the avenue through which all that Ethereum was stolen. So type checking would ensure that if a smart contract is created, there can't be anything like a DAO bug. It has to be correct by construction, if for lack of a better word.
Well, yeah. I mean, there's some subtlety in saying what correct is,
right?
But
yeah, it's less prone to those types of with behavioral types. Will it be? I almost got the impression that it's like 100% guaranteed that these types of vulnerabilities won't be able to occur. That seems to set a pretty high bar at 100%. But is that even realistic? That is behavioral types, and once that gets implemented, is that create this barrier of confidence?
Well, it doesn't say no one can ever make a mistake. It says that there are tools for eliminating classes of bugs. Yeah, so like you in a PHP program, you can pass a string where you were supposed to pass an integer, right?
Mm-hmm.
And there's nothing in PHP that can stop you except being really careful.
Mm-hmm.
Right? But if you're writing Java, you can put types there and your program won't compile.
Okay.
Right? So that's the class of errors. Now, nothing says that in your Java program, you could just type everything object, right?
Mm-hmm.
And then you'd be shooting yourself in the foot because, now you're back to where you started.
Okay.
So nothing says you can't aim the gun at your foot.
Okay. Yeah.
Yeah, I think that the behavioral types formally describe behavior that the system will have. It doesn't necessarily eliminate other behaviors that are not in contradiction to the behavior you specified. So,
well, yeah, they do. I mean, if you give it a type, then it makes sure that anything that not of that type, doesn't compile. So it's not like the DAO bug will be inexpressible because we have behavioral types. What it'll mean is that there'll be a thing in the library, just like integer or string, that says, no races. And you'll just put contract : no races.
Okay.
And it'll be that easy to make sure that the DAO bug doesn't happen in your code.
Okay. And is there a difference between behavioral types and the logic as a distributed law algorithm? Are they the same thing? When we speak of one, do we speak of the other, or is there a distinction between the two?
They're not the same thing. The logic as a distributed law is one way of making behavioral type systems.
Okay. That was helpful.
It's a generalization.
Gotcha. So you're not necessarily going down that path of the ladle.
Correct.
Okay.
So behavioral typing is something that's done at compile time rather than run time.
Yeah.
So it doesn't imply addition to the virtual machine, the basic Rolang interpreter.
Right.
It's only before the code gets to that point of hitting.
That's my understanding. Yeah.
That we have to be concerned about the typing, because we can be confident that the typing will be obeyed by the code, even though it's not checked at runtime.
Okay.
And and what you just said, Jim, would that be true for Ladle as well as what Dan is doing here? Does Ladle adds nothing to the VM either, right?
Right. I mean, it may imply some changes for optimization, because that never ends. But
and there was one question brought up in the I'm sorry.
They sort of meet orthogonally.
What meet orthogonally? The VM and Ladle?
No, Ladle and behavioral types. Okay, they both provide, I don't know, Dan?
Ladle is a way of making type systems, is what it is.
So it's just more general than what you're doing here.
Right.
Okay.
Yeah, as a concrete example that I believe I understand is, when you have a type and you want to make collections over it, that can be done in a generative type of way, and the collection then is also a type. And there can be, of course, many types of collections for one given type. So that's an example where you wouldn't have to roll your own collections, and you would have a more expressive type system. Does that jive with you, Dan?
I'm not sure what you were saying.
Okay, well, I'm not an expert on it, but just to summarize again, I believe that one of the Ladle things it enables are collections as their own types. And so when you have a thing called a class and you're making a collection of that class, then that's also a new type. So that's not rocket science, but that's one of the patterns that Ladle employs.
Yeah.
And Joshi felt that Ladle might be a couple of years away. How do you feel about that, Dan?
I haven't run into anything that we kind of need to wait for Ladle for, so I haven't really concentrated on it very much. So like I said, Ladle is a way of making type systems, and as far as I can tell, we've got one, well, maybe not. What the heck?
Well, I think the strong behavioral type checkers or spatial type checking and at an advanced level requires some of these consistencies down in the language. And of course, it's easier to do in the mathematics, but when we're talking about Rolang may need some additional functions as well, or features as well, to make it make the type systems, or sorry, the model checkers be more powerful.
I'll just show you something real quick. So I was going through this paper somewhat. There's a bunch of stuff with categories that I have a very big understanding of. Okay, then they recap row calculus here. The ladle algorithm takes in things like row calculus or lambda calculus or things like that. So the ladle and the row calculus, like Jim said, are kind of orthogonal. Let's see. And then, okay, right, here it is. The logic generated above, adding blah, 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 is equivalent to the logic we generated by hand in 15. And 15 is the namespace logic paper.
Okay.
So that's this one. So this is the code I'm trying to and Greg wrote an implementation of this thing, at least part of it, everything except Brady's fixed point and quantification. So I've been taking his code and converting it from OCaml to Scala. So far, this is, good enough for me, and I haven't needed anything more interesting that you might get out of Ladle.
And that's because of the type of coding you're doing in JavaScript?
No, this is for row calculus or row line. Yeah, these are types for row calculus processes. Like this is the type of the nil process, and this is the type of all processes. And if you have some type, you can put negation in front of it, and you can say all but those, things like that. Well, like this is the type of sending to anything that A describes, sending a process that phi describes to a channel that A describes. Things like that.
Okay. Very good. Thanks, Dan. We appreciate that.
So did this run? It's weird. If I can debug this. Just to catch everybody else up, and maybe because thinking out loud, can help. Let's see.
So which one of these components are you currently working on? Are we seeing on the screen?
I'm working on structural equivalence right now, which is not even to type checking yet.
Okay.
So the bug I'm working with is I've got this thing that's basically, there's different syntax in Rolang you can write it like that, right? In Scala you write this, right? I've got this thing that's 3 processes in parallel: the stopped process, sending 0 to 0, and sending 0 to 0, all inside of a par. And then I've got another one that's 1 par at the top with 2 things in parallel. The second one is sending 0 to 0, and the first one is the stopped process in parallel with sending 0 to 0. And those are supposed to be structurally equivalent because 0 in parallel with anything is just the anything, and so that gives us just this. And then likewise, 0 in parallel with anything should give us just this. And that gives us just that thing in parallel with just this thing. So they're both structurally equivalent to this thing. And so I'm trying to test that. So where's my test case? Yeah, so this is sending 0 to 0, and the paper sending is called lift for whatever, who knows why. And at 0 is written quote 0. So the first one is par list 0 send 1 send 1, and the other one is par list 0 send 1 send 1. Is anybody with me so far?
Yeah, I'm actually following you. Yeah.
Okay.
Tracking.
Okay, so I've got 2 different. The row calculus paper will tell you how to tell if 2 things are equivalent, and the OCaml code had an implementation of that, and I converted it to Scala, and so here we go. We should be able to tell that those 2 things are equivalent, all right? And then another way to do it is to normalize each one of them and compare them. And we're not there yet because it's crashing in equivalent, I think. Or no, it isn't, it's crashing in normalize. Or where is it crashing? Let's see. Oh, right, it's crashing in the earlier normalized test. Crashing in this one, I think. Let's see. Let's stop that. And simple normalization won't go. Wow. How does it even get to flatten? Because this is basically where's P1? Oh, right, okay. So P1 is, so N1 is 0 par 0 quoted, and we're going to send 0 to that address. So this is so P1 is I guess you're right. They do processes and squirrely braces usually. I think parentheses work, but that's not, if you ask the thing to print it out, it will print it this way. Okay, and I think that if we simple normalization, right? If we normalize this, that should normalize to just add nil. that make sense? Because nil par nil is normalizes to nil, right?
Okay.
So that should just go to nil. So
Right.
this should go to at nil, like that.
Mm-hmm.
So that's what we're testing here. So now if I tried to run it and it did a Stack Overflow, so I'm going to do a debug. Because I set a breakpoint here. And, oh, that's a different thing. Never mind that one. I was trying to debug some other problem earlier. Okay, here we are. So we've got a list of zero and zero as in our list. Okay, so that's not an empty list. And it doesn't start with a par. So we should just take the first one and flatten the rest. Oh, I didn't flatten the rest. I flattened the original list. So I was never going to make any progress, right?
Oh, okay.
It's just going to go. Zzz. Now let's try. Still losing. Equivalent AB was false. What if I do it the other way around? Okay, well, it did get normalized. PA equals normalized PB, right? Yeah, and I know there's a bug in equivalent. So maybe that's not so bad. Where's the thing that says show? Okay, well, I fixed one part of the button. So the problem with equivalent was that I wasn't handling this case of a par inside of a par. I think the row-camel code doesn't handle it, and maybe that's because it wasn't designed to. It could be that it's only designed to handle data structures that come out of its parser, and the parser never generates that. So maybe I can ask Greg or something. Anyway, yeah, the equivalent. Where is it? The algorithm for process equivalence is kind of hairy. There we go. Yeah. This bit where it tests whether par is commutative and associative and stuff, this thing is pretty hairy, and the bug is in here somewhere.
Okay.
A lot of it is simple. You know, it says, okay, the zero process is equivalent to par nil. Okay. Nothing in parallel is the zero process, and likewise the other way around. Um, 0 is equivalent to as many zeros in parallel as you like. So that one says that is the 0 equivalent to the first thing in the list, and the 0 is equivalent to the rest of the list in parallel. And then this one says, if you're doing them in the other order, switch them around and try again. And this one says, if you've got inputs, that is 4s, if you've got a couple of different 4s, and then you can check to see if they're if the names they're coming from are name equivalent, and then if you substitute the stuff into the continuation, if the continuations are equivalent. So that's like for A from X to like so these are equivalent because like X is name equivalent to X. That was trivial. And if you take X and substitute it in for A here, is it X that it substitutes in? I think so. You take X and substitute it in here, you get something equivalent to substituting X in here. Because Z bang X is equivalent to Z bang X bar nil. So, in other words, this name here, it doesn't matter what you write there. That's what sort of alpha equivalence is. It's like when you write in Python, if you write f of X, it doesn't matter whether, if I change this to Y, it doesn't matter, right?
Mm-hmm.
That's kind of what alpha equivalence is.
Okay.
And then par is associative and commutative. That one's tricky. I don't like that one. Haven't really fit it all in my head at once. And then this one basically says if you've got 2 pars and the second one has at least one thing in it, switch them around. And check the other way. And then zero is the identity for par. This says if you've got something and you're testing parallel proc list, I'd have to think about that one. The way this partition thing separates this proc list into the things that are equivalent to proc 1 and the things that are not. So if there's nothing equivalent to proc 1, then there's a mismatch. And if there are some things equivalent to proc 1, then the rest of them have to be equivalent to 0, I guess. And this again switches the order around, and then this just says, oh, well, if they're the same thing, then they're equivalent. So parts of that are easy to understand, and parts of it are hairy. What else is fun? I did get what's this here? Oh, sorry, that's somebody else's code altogether. So this is, oops. What other tests did I get going here? Right. Here's some actual type checking. So let's go back real quick and look at, oops, not that. Right, so this thing is the type of all processes. And so I just said, well, 0 is a process, so it satisfies true. That one's pretty easy. And then double negation, 0 also satisfies not true. And then there's a type for descent. So drop N1 satisfies descent N1. Mixture is for parallel, I think. And so the 0 process satisfies mixture 0. And drop doesn't mix with 0. So those are pretty basic tests. And then I said, oh, okay, so I've got like, some really trivial things going. I did manage to port, I think, the entire, this is the behavioral type checking algorithm that Greg wrote. It's only 150 lines, so it wasn't too bad. And basically to port the OCaml code, it's really just copy, paste, and move the parentheses around. So that was kind of nice. So this is supposedly the whole algorithm. And so I thought, oh, okay, now I'll go look for all those interesting examples that motivated this whole thing. I don't know what that's all about. Oops. And so I went and looked for the DAO bug. And the first example in the DAO bug paper is this cell type. But it uses these two things, which are in this logic, but not in the OCaml implementation. Darn. So then the other behavioral type checking algorithm that we've got in our pocket is the one from this SLMC tool. Nope, this is the ladle paper, sorry. Oops. This is kind of cool. It's got, the examples are things like, this is a cell phone network where you can switch base stations and stuff like that. And the properties are that it's deadlock free. So that was kind of cool, I thought. Is that sort of, isn't that kind of cool that you can write it's deadlock free in one line?
Sounds cool to me.
Yeah. I mean, so, one of the state of the art problems is like finding deadlocks in Go programs, right? Mm-hmm. So there's no way to write in one line, this Go program is deadlock free. Mm-hmm. You can do it for Rust, but you can't do it for Go. You can't compile programs that have deadlocks. Well, not deadlocks. Data races. You can have deadlocks in Scala or in Rust. Anyway, so this is a system that can check properties like that. And it comes with some code, some source code. So that's not it. Oops.
So this is a model checker, like Ladle is a model checker.
Well, you can have model checkers for logics built with Ladle, but I don't believe Ladle is a model checker. Ladle is an algorithm for generating type systems. Right?
Okay.
That's my understanding of it anyway.
And in this paper, they talk about this as being spatial logics.
Yeah, that confused me. I'm not real clear on what's spatial type checking and what's behavioral type checking, but when you actually look at the paper, it talks about it being a behavioral spatial type checker or something like that. Let's see.
Okay, yeah, I saw that too, and I was all hung up on the difference between the two, and I started searching on spatial type checkers, and all it people were wanting to talk about was like in these database systems.
Yeah, I think that for me, and I know this is not accurate to this paper, I think of spatial as something would lay out in storage, whether it be a database, a flat file, or even in memory. And behavioral is, how the interactions happen at runtime.
That's certainly intuitive. That might be right. Somebody once said that it's a spatial type checker if it handles associativity and commutativity, but I don't really know if that's right. This thing is kind of nice. This is the manual for this doodad, and it's got a certain amount of Greek letters and theory and stuff at the front, and then it switches to like, aha, ASCII stuff you can type in and run.
Yeah, that did look. It went from totally abstruse to something I could wrap my head around.
Right. Okay. So and it comes with source code. So, for example, here's the OCaml code for here's the type of our formulas, and it's got a lot of different kinds of things in their formulas. But anyway, then I took that and sort of did copy and paste. So if I close up the row stuff and I open up SLMC, I haven't even gotten as far as formulas. I've only gotten as far as processes. So their notion of a process, they call their stopped process void. They have par like we do, and then they have sum, which is a choice operator, which is not primitive in row calculus. I think you can build it, but it's not primitive. And then they have new, which is again not primitive in row calculus. And activity is the same as lift. Maybe activity includes sending and receiving. I'm not sure. And then they've got test, which is kind of like rolling match. And I don't know how you build that in row calculus. And then they have var, and I'm not really sure what that is. This is how you do the free names. And this is how you print them. Anyway, so this code here, Scala is more wordy when it comes to that stuff, but it's pretty straightforward. You just par of AST node. Well, it's got AST node ref means it's mutable, and I've kind of dropped all that aspect of it. They have some performance optimizations where they use mutable stuff, and I'm like, I'm not going to bother with that. Anyway, par of two nodes, par of AST1, AST2. Okay, sum of a couple of nodes, sum of a couple of nodes, new of a list of strings in a node, new of a list of strings in a node. Right, pretty straightforward. like I said, you just copy and paste and move the parentheses around. Well, there's differences like in Scala, the parts have to be named, and in OCaml they don't. So I just made up names. I used names that were used elsewhere in the code. What did I do? Okay, I can compute free names and I can print them. Yeah, this was kind of interesting because in the test, I think I actually found a bug in their paper. So the first example, yeah. So that example, new secret in hand, send secret 0 or erase 0. I think it's like this. What did I do with new? Oh yeah, new secret output secret on hand, and then void, and then blah blah blah. Anyway, that was the way I interpreted that using the data structures. And then when I print it, this angle bracket syntax is actually not process syntax. It's actually formula syntax. So they've got a typo in their paper. I'm pretty sure that's supposed to be round brackets.
I'm curious about ignoring mutability. I mean, Golang is stateful.
Oh, okay. So this is at a very somewhat low level. Let me give you an example here. Okay. So in their implementation of free nodes, they take an AST that is one of these formula data structures, and then they take a hash table, and they don't return anything. They just mutate the hash table. So it says, okay, if our process is void, then we're not going to do anything. If our process is two ASTs in parallel, then we will mutate the hash table with whatever free names are in one, and then we'll mutate the hash table with whatever free names are in the other, and so on, right? So instead of returning the free names, it just mutates this hash table, right? So what I did is instead, I kept the name to be HT because that was easier than renaming or whatever. But basically, this thing takes an AST and a set of names and returns a set of names. The set of names is sort of the context. So I don't mutate anything in here. If it's a stopped process, then it's got no free names. If it's a parallel process, it's the free names in the first one, union the free names in the second one, and so on. That's what I mean by I got rid of the mutability. And I've only done a little bit of their code so far. So it's only a change in the implementation. It's not a change in the system that I'm implementing, I don't think. Does that make any sense?
Well, it sounds cool, that you can really eliminate mutability from the problem.
Well, it's just from the implementation. Basically what it means is that I'm going to allocate more memory, and my implementation is probably going to be slower, but easier to think about.
Yeah. I think about the events. Well, but I don't know. The ordering is important. And I guess you're embodying the ordering by.
Order is important sometimes and not others, right? You know, if you write P par Q, it's the same as Q par P, right?
Right. Yeah. And the 4 is in the namespace. So it provides context. And I think spatial as in the time space, in the ordering space.
Something broke up. Say that again. You think of spatial as
time spaces, where you have orderings as dimensions. Or perspectives or contexts.
Okay, is that similar to what?
Well, spatial is really across the time perspectives.
Is it similar to the way that Ed was describing it?
Similar to what?
Is that similar to the way Ed was describing it?
I think so, yeah.
Okay.
Well, they talk about modalities and you know, things like before, after, above, below.
Right.
Before and after are the kinds of things I think of as behavioral. Above and below, I would think of as spatial.
Or near, or so on and so forth.
Where did you see near?
Yeah.
Well, I invented that one.
Okay.
But think of it this way, or I think of it this way. Everything at a sphere of 10 meters, let's say, from my perspective, happens simultaneously. When I, or information, I receive information from anything 10 meters away in any direction simultaneously. And that defines a space.
Okay, yeah. There's a few other concrete examples that I found in the papers and stuff. So the cell type.
Now, so that anything in par is equal distance. And the distance is in
the number of hops or whatever.
well, yeah, the delay elements, the 4s.
Yeah. I had a little bit of fun. There's this, he's got a type for XML, which I thought was kind of interesting. That's one way of writing it, which is kind of, I had fun with the web tech tools. It's in, right. This formula there is supposed to be the same as that formula there. I was like, what is all this stuff? I can't, get all that all in my head. So I forced myself to write it down in tech, and then I made a couple macros like lift and act for activity and stuff like that. And that allowed me to figure out what the structure was.
I wish we had some other people on this call who are more into doing it at that level. My issues are a little more basic. Let me know if I can jump in and.
Yeah, I guess I'm running out of steam a little bit. Oops, I didn't want to do that. Oh well.
Just for a minute here.
I'm still not looking at anything that has C processor macros in it, by the way.
And why is that, Dan? Because of the danger?
I dealt with the C processor and malloc for the last time in 1996.
Okay, so we have this Rolang here. We loop for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Are you sharing? I'm missing something.
Yeah, I'm sharing.
I see it.
I see it.
Okay, I don't know what I'm doing wrong.
Find it.
I've lost a window somewhere. I don't know. I can see participants. Okay, well.
So we loop through these, and but each iteration of the loop is executed in par, so that the ordering isn't determined. And then we run this a few times maybe, and we can get different orderings of the output. So I guess there's structural equivalence in the two outcomes. And
I'm going to try to rejoin.
Okay.
I guess I was considering this because I was wondering about, getting consensus. You have one ordering and another ordering, and wondering how that relates to structural equivalence, or if it relates to it. I'm sort of thinking of consensus models where I guess the structural equivalence means that that each of these is a correct execution. You see that? Yeah. Can you see it now, Dan?
Yeah, I can see it. Dan, are you able to see Jim's screen now?
Dan's muted.
Yeah, Dan, you're muted.
Not really a big point. Whoops. I guess I should keep that on. Can't hear you, Dan.
There can be two executions of a contract that are not equivalent to each other. Structural equivalence is between two processes. Yeah, the consensus comes in that one of the validators runs the thing and decides on an order and then publishes it. And then everybody else goes, that's a correct order. There may be others, but we'll all agree on that one.
I guess I'm wondering how we determined that it was correct. If we would get a different result.
No, well, we don't independently run it. We just when they publish their block, they publish the trace, and we just go through the trace and we say, oh yes, that's a correct trace.
Okay, because that's. I thought we were just publishing the final state.
No, the block actually has all of the COM events.
Okay, thank you. Because I talked to Greg about it, and I guess I didn't understand. He was talking about it as state.
Yeah, I was wondering about that too. That's one of the nice things you can learn by studying the proto files. It's got all the details of what's in every block. The one thing I don't understand after studying all that stuff is how is this thing going to scale at all? Everybody stores every version of the whole blockchain.
Yeah, that's why it came into garbage collection.
And sharding. No, that's one of my biggest concerns about relative to the scalability promises. If you have to run a node that is terabytes of data, that's pretty challenging to get a lot of node operators.
And it all has to be in RAM as far as I can tell. Or at least virtual memory that could, anyway.
Yeah, certainly every piece that isn't, that has a pending send or receive on it, which is a lot.
Well, nothing ever gets put into cold storage or anything. It's just all level space.
I thought they were implementing that, but I could have missed.
Well, Jim. I do think there were answers of separating out sort of the historic DAG that could be on disk versus the active piece, but I've never heard an answer that satisfied my intuitions that don't conclude basically what Dan said, that it all has to be in memory or the near equivalent of memory.
Maybe the old versions don't all have to be in RAM, but the whole current tuple space is all in at least virtual memory, as far as I can tell.
Right. So if you set up a lot of listeners, whether it be on old stuff or new stuff, it's all in RAM, I think.
Yeah, I guess only the pending stuff is in the tuple space, isn't it?
But that still could be a lot.
Yeah. All listening contracts.
Brings me back to garbage collection. I mean, the only things that can be referenced in the long term are things that are connected to a a URI in the registry currently. And well, I think there should be a way of destroying those URIs as well. One of the first principles that we learned in the development of the electronic information exchange at NJIT was never create anything you can't destroy. That was a mandate of Murray Toroff, an EFF pioneer.
Something tells me that the way we're going to destroy anything in the Mercury time frame is to just throw it away and do Venus. But yeah, I don't see there is one ticket that's about local garbage collection, but it's not scheduled anywhere, and I haven't seen any concrete plans for global garbage collection.
That's very true. I mean, most of the evals on robot are testing, which where everything is thrown away immediately, and yet it ends up in the tuple space.
Jim, weren't you running out of memory on your node quite often? You weren't.
But the usage is not that great. I ran out of memory once after 2.5 months.
How much RAM do you have allocated to it?
Let me look here.
You're not sharing.
I'm not sharing. Looks like right now I'm just taking the default, whatever that is.
No, I meant do you have a 1 gigabyte or a 16 gigabyte droplet or whatever?
I have, I believe it's 4 gigs.
It's pretty modest.
Yeah, and if we look now, it really hasn't used much memory.
I've got another topic on my mind, by the way.
Okay, well, wait 1 second here. We'll just look at, where is it? It shows where to go. It's using 15% of the memory after running a couple of weeks. So it's not a problem at all. But of course, once you get running all these millions of contracts, then it becomes a problem.
You said it, doggy.
Okay, take it away. Where am I? Take it away, Dan.
Oh, now for something completely different. I caught up on the financials are finally out. And is it Barry? Is that his name? No.
Yeah, Barry Cinnamon.
Yeah, he had a very coherent update. And
I really appreciate him. Yeah.
And I went and read the board minutes. Have you guys checked out the board minutes lately?
Yes.
very lively discussion between Chris B and Greg about timelines.
Yeah, did Chris say he couldn't imagine it before July? Is that what it was said?
Yep.
Yeah.
And Greg said we should wind up the co-op if that's what we're aiming for.
Greg is always ever optimistic, which is a good and a bad thing. And it's caused a lot of pain in the past, actually,
Yeah.
his optimism.
Dan, where could we find those board minutes?
It's rchain/board in GitHub.
If you got a link, perhaps you could put it in the chat.
Yeah. Are we using any particular general? Oh, you were probably talking about Zoom chat.
Yeah, Zoom chat.
Where is Zoom chat? There it is.
Great, thank you.
I think like November 6th was the last time I had read board minutes, so I read November 9th, December 4th, 21st. Where's the, let's see, January 3rd, is that the one?
How functional would you grade our board to be?
Well, these days it's kind of firing on all cylinders.
Awesome.
Sort of. That would have been fine if it had happened 9 months ago.
Yeah.
They're firing on all cylinders on the decision of whether to file for bankruptcy.
Oh, geez.
Yeah, if we turn off recording, I can elaborate on that. What?
I would like to hear Ed's confidential thoughts on this.